So this morning, Aduro had a press release. Aduro announces completion of mechanical assembly of its R2 plastic reactor. This is what I've been waiting for months, the R2 for plastic. So let's read some of the things in the press release. Aduro, a Canadian developer of patented water-based technologies to chemically recycle plastic and transform heavy crude and renewable oils into new era resources and higher value fuels, announces it has completed construction and mechanical assembly of its pilot scale hydrochemolytic continuous flow R2 plastic reactor. Congratulations. Plans for testing and certification are in place, and final certification by the Chemical Standard and Safety Authority is progressing, with registration expected later this month. Once certified, the reactor unit will be moved to the newly expanded laboratory in London, Ontario for final testing and commissioning. The R2 plastic unit is the company's customer engagement unit and is designed to handle various plastic feedstock such as polyethylene, polypropylene, and polystyrene as single stream materials, followed by a mixture of these feedstocks streams. So if you've been following the story for a while, you know that this R2 is all about customer engagement, because up to this point, the company had a story, right? It had a technology, and it was operating on a batch system, not continuous base system. So most companies want to see the R2 continuous, right? I know that there was a press release that Aduro has been accepted to the Game Changer program, and it's a big deal because Shell chose Aduro's technology based on the batch system, not because the R2 wasn't finished. So this is a big deal because now, after, of course, this is moved into the newly expanded laboratory, which I believe it's in Q1, that's when companies will be able to give them the feedstock and test it, and that's going to, I believe, accelerate future deals. So let's continue. The R plastic will also be used to evaluate the impact of materials found in multi-layer plastics such as paper, paperboard, polymeric materials, materialized layers, and aluminum foil, effectively advancing Aduro's plans of processing higher contaminated materials which are currently rejected by the current technologies. I know I said it many times that Aduro's ability to recycle a contaminated plastic is a big deal because the other technologies, the competing technologies, can't really do that, and most of the feedstock is rejected as a result of this. This is important data that will support the company's established scale-up and optimization program for the scale-up pilot R3 plastic. In 2022, the company undertook several projects, including the construction of both the plastic upcycling and bitumen upgrading reactor units, the construction of a flash drum unit for pre-processing bitumen feedstock, and expansion of laboratory facilities and laboratory capabilities that will centralize the company's resources, more efficient execution of our R&D scale-up and commercialization plans. Completion of these projects positions the company to execute in 2023 the R2 reactor research and testing optimization program, the implementation of customer engagement program, and then delivery of reactor unit design, equipment procedures, fabrication, and commissioning of the scale-up pre-commercial R3 reactor unit. Accompanying this update, the company has produced a video walkthrough of the R2 reactor featuring Our chief scientist, Anil Javar. This is Anil is the person that I met in person, and if you watch my videos, you saw Anil on my videos. The video can be viewed on our YouTube channel. So let's take a look at one of the videos. Both of them are on Aduro's YouTube channel, so you can go ahead and look at it. But let's together look at the walkthrough.
Hi, I am Anil Jawar, Chief Scientist at Aduro Clean Technologies. At Aduro, we are working on the development of platform technology for chemical recycling of plastic called hydrochemolytic technology. It's a simple water-based process which is capable of upcycling plastic into high-value feedstock and platform chemicals to enable circularity. It's a unique chemical conversion process which could be achieved using conventional processing equipment. This is
Here's the baby, R2.
Reactor system for upcycling of plastic into high-value feedstock and platform chemicals. In tank 1, we have water and catalyst. In tank 2, we have bio-based renewable in situ reducing effluent source. They are co-fed into the reactor using a high-pressure pump. This is an auger to fill the hopper for the extruder. We can feed in polyethylene, polypropylene, polystyrene, or mixed plastic using this auger into the hopper, and they are fed into the extruder. The extruder is used like a pump here. We increase the temperature of the plastic and push the material into the reactor system. In the reactor, the plastic come in contact with our co-feed, and depending on the process conditions, which we can adjust by adjusting the temperature or pressure or even the space-time. And depending on the process condition, we get a different quality of the product. Once the reaction is complete, the material leaves the reactor system and flows into this twin separators, where we can maintain different temperature to get the fraction, desired fraction. So depending on the process condition, we can get high molecular weight waxes, or we can also get low molecular weight hydrocarbons, which are suitable for naphtha cracker feed. The non-condensable gases leaves top of the second separators and are collected. So this is, in short, our complete hydrochemolytic process.
Very exciting. So, tomorrow I'm going to publish the interview that I did with Mina and Ofer, and it's about the questions that you guys were asked to submit. So be on the lookout for the video tomorrow.